it becomes.
Precisely.
So where does all this data come from?
Well, there are several large public cardiac image datasets that AI researchers use.
Like giant libraries of heart images.
Exactly, each carefully labeled with information about the patient and any relevant medical conditions.
That makes sense. And these data sets are constantly growing and evolving as more research is conducted.
They are.
It's amazing to think about the sheer volume of information that's being used to train these AI models.
It really is.
And speaking of information, it seems like collaboration is a huge part of this whole AI and cardiology world.
Definitely. I'm seeing a lot of mentions of platforms and initiatives aimed at sharing data and expertise.
So it's not just about individual labs working in isolation.
Nope, it's about fostering a global network of experts who can collaborate and share their findings.
Which makes sense because the more data and expertise we can pool together, the faster we can make progress.
Exactly.
And I'm seeing a lot of mentions of platforms like the Cardiac Atlas Project or CIP.
Yes, CIP is a great example.
And also the Cardiovascular Research Grid or CDRG.
These platforms allow researchers to access and analyze massive data sets, all conveniently located online.
It's like having a global library of heart information right at your fingertips.
It really is.
That's fantastic. I'm also seeing that Stanford University is playing a big role with its AII dataset.
Yes, AIMI is specifically focused on developing AI tools for cardiovascular research.
It's impressive to see these institutions leading the charge in this exciting new frontier of medicine.
They're really paving the way.
So it sounds like we're on the cusp of a major paradigm shift in how we approach heart health.
I think so.
But before we get too carried away, are there any challenges or limitations we need to be aware of when it comes to AI in cardiology?
Of course, no technology is perfect.
Right.
And AI is no exception.
So what are some of the challenges?
Well, one of the biggest challenges lies in the sheer complexity of the cardiovascular system.
In what way?
Well, the heart is a dynamic organ with intricate blood flow patterns.
Right.
And accurately simulating those patterns computationally can be very demanding.
So even with all this amazing technology, there are still hurdles to overcome.
Absolutely.
What else?
It's important to remember that AI is a tool, not a magic bullet.
Right. It's not going to solve all our problems overnight.
Exactly. More research is needed to fully understand its limitations in cardiology.
To ensure that AI models are accurate, reliable, and unbiased in their assessments.
Precisely.
That's a crucial point. We need to be thoughtful and cautious in how we develop and implement AI in healthcare,
I agree.
making sure it's used responsibly and ethically for the benefit of all patients.
Couldn't have said it better myself.
Another challenge I'm seeing in the research is ensuring that AI models are trained on diverse data sets.
Yes, that's critical.
Data sets that accurately represent the patient population as a whole.
Right. We don't want AI algorithms to perpetuate existing biases or inequalities in healthcare.
Exactly. It's essential to make sure that AI models are developed and deployed in a way that benefits all patients regardless of their background.
I completely agree.
It's a good reminder that technology, even with the best intentions, can sometimes have unintended consequences.
It's important to be mindful of that.
So where do we go from here? What does the future hold for AI in cardiology?
Well, from what I'm seeing in these sources, the future is incredibly bright.
That's good to hear.
Researchers are exploring some truly mind-blowing applications of AI in cardiology.
Oh, I bet.
And I'm excited to delve into those with you in our next segment.
All right, well, let's take a quick break and then we'll come back and dive into those mind-blowing applications.
Sounds good. So one area that's really fascinating is the development of personalized 3D printed heart models.
3D printed hearts? That sounds like something straight out of a sci-fi movie.
I know, right? But it's becoming a reality.
So instead of just looking at images on a screen, doctors could actually hold a replica of a patient's heart.
Exactly. A physical model created from their own imaging data.
I can see how that would be incredibly helpful for diagnosis and treatment planning.
Absolutely. These 3D printed models can be used to simulate blood flow, test different treatment strategies, even practice surgical procedures.
Wow, so a surgeon could practice a complex heart surgery on a patient-specific model before the actual surgery.
Exactly. It's like a dress rehearsal for the real thing.
That's amazing. It could potentially lead to safer and more effective surgeries.
Definitely. It's a game changer for surgical training and planning.
But where does AI fit into all of this? We've gone from AI analyzing images to AI helping create physical models.
Right. Well, AI is actually crucial in both creating and analyzing these models.
Oh, interesting. How so?
Well, for example, AI algorithms can be used to analyze the shape and structure of the 3D heart model and predict how blood will flow through.
So it's like having a virtual wind tunnel for the heart.
Precisely. You can see how blood flow might be affected by blockages or other abnormalities.
And this information can then be used to design more effective stents, plan bypass surgeries.
Exactly. It allows for truly personalized treatment strategies.
This is incredible. It's a perfect example of how AI is transforming cardiology, taking us from a one-size-fits-all approach to personalized medicine.
I agree. But it's important to acknowledge that we're still in the early stages of this technology.
Of course, there are always challenges.
Right, like the cost and complexity of 3D printing.
And the need for accuracy and reliability.
Exactly. So while the potential is enormous, it's not a quick fix.
More research is needed.
Absolutely.
And it will take time for this technology to become widely available.
But the progress being made is remarkable.
It really is.
I'm confident that 3D printed heart models, powered by AI, will play an increasingly important role in cardiology.
I think so too. It's really exciting.
It is. Now let's shift gears a bit and talk about something that we touched upon earlier.
Okay, what's that?
The massive amounts of data needed to train these AI models.
Right, data is the lifeblood of AI in cardiology.
It really is. And as we discussed earlier, there are already large public data sets of cardiac images available for researchers.
But I came across this interesting concept in one of the research summaries.
Oh, what's that?
The idea of creating a digital twin of a patient's heart.
Ah, yes. Digital twin.
It sounds very futuristic.
It is a hot topic in healthcare right now.
So essentially, it's a virtual representation of a patient's heart.
Right. Created by integrating all sorts of imaging data, genetic information, lifestyle factors, even real-time data from wearable sensors.
So it's like a dynamic, personalized simulation that evolves over time as new information becomes available.
Exactly. And the potential applications of this technology are truly mind-blowing.
Like what?
Well, imagine being able to see how a patient's heart might respond to different lifestyle changes or medications.
All in a safe, virtual environment.
Precisely.
That's amazing. It would be like having a crystal ball for heart health,
You got it.
allowing doctors to predict future cardiovascular events and personalize interventions.
Exactly. And some researchers are even exploring how to integrate these digital twins with electronic health records.
So doctors could easily access and use this information in their clinical workflows.
That's the idea.
We're moving from reactive care to proactive prevention.
It's a paradigm shift in healthcare, and digital twins are at the forefront.
This all sounds incredibly complex. How do we even begin to build these digital twins? It seems like it would require a lot of computing power.
You're absolutely right. Building and maintaining digital twins requires a lot of computational horsepower.
So we're talking supercomputers,
Exactly. But the good news is that these supercomputers are becoming increasingly accessible.
even through cloud-based platforms.
Oh, right. So even smaller hospitals and clinics could potentially leverage this technology.
That's good news. It means that more people could benefit from it.
That's the hope.
But I have to admit, I'm struggling to picture what it would actually be like to interact with these digital twins.
Well, imagine putting on a virtual reality headset and stepping inside a patient's digital twin.
You could see their heart beating, blood flowing through the vessels.
You could even simulate the effects of different interventions.
Wow. That would be an incredible experience for both doctors and patients.
And incredibly valuable for surgical training.
It sounds like the future of cardiology is going to be very high-tech.
It's a truly exciting time to be in this field,
We're witnessing a convergence of cutting-edge technologies.
with the potential to revolutionize how we understand, diagnose, and treat heart disease.
It's all happening so fast.
It really is incredible pace of innovation.
This deep dive has been amazing. We've covered so much ground today.
We have from the intricacies of heart imaging to the mind-blowing concept of digital twins and virtual reality.
It's incredible to think how far we've come. I mean, it really feels like we're on the verge of a whole new era in cardiology.
I think so.
You know, we've talked about AI analyzing images, predicting risks, even creating those incredible digital twins.
Right.
And then we have virtual reality letting us step inside a virtual heart.
Yeah, it's pretty wild.
Where do you even see things going from here? It's hard to even imagine.
It's hard to predict the future, for sure. But
Of course.
based on the research we've looked at, I think it's safe to say that the future of cardiology is going to be increasingly personalized,
Okay.
predictive, and collaborative.
So those are the three big takeaways: personalized, predictive, and collaborative.
I think so, yeah.
So we're moving towards a world where treatments are tailored to each individual patient.
Right.
Future risks can be anticipated and potentially avoided.
Hopefully.
And global data sharing is going to speed up everything.
Exactly. It will accelerate the pace of discovery.
So AI isn't just a tool for doctors.
Right, it's bigger than that.
It's like a catalyst for a whole new way of thinking about heart health.
I like that, a catalyst.
Which brings us back to something we talked about earlier.
What's that?
AI isn't meant to replace doctors, is it?
Absolutely not.
Okay, good. I was worried there for a second.
It's about combining the best of both worlds.
What do you mean?
The intuition, experience, and empathy of human doctors
Right.
with the analytical power and speed of AI.
So it's a partnership where
Yeah.
AI helps doctors make better decisions and provide better care.
Precisely.
It's reassuring to know that human expertise is still at the heart of it all.
Couldn't agree more.
I was getting a little worried that the robots were taking over.
Not yet, at least.
Now, before we wrap up this deep dive,
Okay.
you said you wanted to leave our listener with something to think about.
I do. A final thought-provoking question.
Okay, I'm all ears.
So we've seen how AI is being used to analyze images, predict risks, and even create virtual models of the heart.
Right.
What if we could take this a step further?
Okay, how much further can we go?
What if AI, combined with 3D printed heart models and virtual reality, could one day help us eradicate heart disease?
Wow, that's a big question.
It is a bold idea, for sure.
It sounds almost like science fiction.
It does, but it's not entirely out of the realm of possibility.
I can see how these technologies working together could have a truly massive impact on heart health.
I agree, it's a goal worth striving for.
It is.
And while it's impossible to say for sure what the future holds, I think the research we've discussed today suggests that we're on the right track.
An exciting track.
Definitely.
This has been an awesome deep dive.
It has.
We've gone from the tiny details of heart imaging to the mind-blowing potential of digital twins and virtual reality.
I know this stuff is really incredible.
It's left me feeling both informed and incredibly optimistic about the future.
That's great to hear. And remember, even though we've covered a lot of ground today, there's always more to learn and explore.
That's true. The learning never stops.
So stay curious, keep asking questions, and most importantly, take good care of your own heart.
Great advice. Thanks for joining me on this deep dive.
It was my pleasure. Thanks for having me.